What's up guys, this is Victor with the RF Performance. In this particular video, we're gonna show you how to put together and achieve your bearing clearances on an Fa20 along with your ring end gap on a following video, piston to wall, rod clearance. Right now we have already done our ring end gap, piston to wall, and we're gonna start working on the main clearance for the journals on the crankshaft. So we're gonna put together this block, insert the bearings, close it, torque it, and insert a bore gauge along with the micrometer into the crankshaft, and that'll give us our oil clearance for our main journals. If you do want to see content like this, subscribe to our YouTube channel, as we will continue to put out content on how to build your own motor, how to achieve your clearances for your bearings, piston to wall, ring end gap, and much more. Not just on Subaru, but we're gonna go ahead and tackle GTR short blocks, Evo motors. As you guys can see, we have those getting prep for the machine shop. Follow us on YouTube, Instagram. The next step is insert all your bearings. As you guys can see, this is your last bearing along with your thrust washer. Okay, so these are all inserted. So what we're gonna do, we're gonna close the block, torque it to spec, and then we'll continue to measure for that journal clearance or oil clearance from the main journals on the crankshaft. So let's go ahead and do that. Now that you have followed your OEM torquing sequence to torque your case halves, and you have achieved your bearing crush on the main bearings, you should have a close to a perfect circle on the bearings. We have perfected the OEM torquing sequence, and we achieved tighter tolerances when it comes to the crank journals. So now we're gonna insert our bore gauge, like so, to achieve. So we insert, and now we look for a perfect zero. It's a little difficult sometimes because it's a very, very small place where you put the measuring bore gauge. So now you have achieved it closer to zero, which is sometimes becomes a little on the difficult side. Yeah, it's a little difficult sometimes to do with one hand. So you guys can see it's almost zero. So I'll adjust that once I get off this camera. But you guys get the point. So we do want, this one's gonna be easier because there's more room. So if we want to zero that one, we insert that center and we achieve a perfect zero, open down. So we have achieved true zero on this bearing inside. So we do that with bearing 1, 2, 3, 4, and 5. And we compare that to our crankshaft. So we're gonna go ahead and get the crankshaft prepped and we start measuring. See you in the next segment. As we were talking, now we're measuring we're gonna zero out our bore gauge to the diameter or the size of the main bearing so we can get our oil clearance, and we'll move on to that. So as you guys can see, we have already zeroed out our gauge to this particular journal, zeroed out. So now we're gonna go ahead and move to our crankshaft. So we're gonna zero out our crankshaft with this micrometer. So we're gonna make sure we're not over tightening. We're gonna position this properly. We're gonna go up and down a few times, and we're going to make sure we don't create any gaps. So once you're done, whoops. Once you have found your true zero for this journal, you shall not see any gaps on your endpoints here and here. It should be gapless. So once you have that, lock your micrometer, and it should be a very slight resistance going in and going out. You should not feel any bad resistance. So now we're gonna go ahead and lock this in place. Give it a quick tight. So now what we're going to do is we're gonna find the distance between the crankshaft and the bearing by using our bore gauge. So remember, we have 0, our gauge, to the journal, and we have 0, the micrometer, to the crankshaft journal. So now what we're going to achieve and measure is our oil clearance, which we are dead on at 1/1000th oil clearance. So you guys can follow the gauge. And as you guys practice this, you guys will see that it becomes easier and easier by time. So right around, it's dead on 1/1000th. So it's perfect within spec of how we like to set our motors. And we continue to do the same process of journal 1, 2, 3, 4, and 5 by zeroing our bore gauge to the journal and by zeroing our micrometer to the crankshaft journal. We will achieve and measure properly without any guess our oil clearance. Thanks for watching. In this particular process, you don't have to really spread it all over the bearing because you're going to spin the crankshaft, and that will transfer the entire lube all across the bearing. So once you do that, once you have that process all done, you go ahead and bring your crankshaft in place, bring the other half, silicone this entire area, put the O-rings where they belong, close it, retorque it, and then we follow into something called thrust play or thrust clearance per se, which uses this thrust bearings here to achieve a back and forth specific clearance of the crankshaft. Too much, no good. Too little, you can actually jam the crankshaft in place and snap it. So it has to be always a sweet spot. Too much, it will run, but you will have problems. Too little, you will have problems. So again, you have to have a balance of absolutely everything. So let's go ahead and do that. Assemble the crankshaft, case block, and measure the thrust, and then we move on to the connecting rods and the bearings, and then that'll conclude the whole assembly process. All we do is just insert the bearings. If you made it this far, that means you like the content we produce and you want to learn about engine and how to put them together along with any automotive procedure, including tuning, engine building, engine repair, engine diagnostics, and much more. And eventually we'll do a segment that we called Shed Talking, where we take apart motors that were put together by another shop or another place, and we do a reverse engineering or reverse process. So we got to set this to our specific torque target that we have configured over time, and we're going to follow the torquing sequence in a single swing. So there's no shaking, there's absolutely no issues. We try to use our complete body to achieve this. So now we will move to the outer ones. Single swing. Keep the hand stable and steady. And now you do one last pass on all of them to make sure you're at the target torque. This one, I normally just go from the inside out. My preference, you can follow OEM sequence again. So So now that the block is torqued, we go ahead and stand it on its back, and I would check, make sure that crankshaft is nice and tight. There's no drag. By nature, you're going to feel a drag on it, but you should not feel it jamming, okay? So we span that really good by hand, should spin nice and easy. So now what we're gonna do, we're gonna set up something called, this is called your thrust clearance. So I have this nice and handy. And make sure you pick a section where you know nothing's gonna go there, that you will not damage. Otherwise, you could get into something that needs to be silicone or sealed, and it's not gonna seal because it'll put a little mark in there. So just be cautious on how you do it. Set up your dial gauge. Doesn't matter the reading that you get, as long as you can track it. You tighten your rod. We let the gauge settle. Now with the screwdriver, we're gonna insert, pick a spot on the crankshaft, and this is really, really tight actually. So we might need to pick a thinner one. There we go. So see, now once you look at the gauge, we move 1, 2, 3, 4, 5, 6 thousandths. 6 thousandths. So if you look straight at the gauge, our thrust clearance, it's 6 thousandths. So this block is in spec. You can actually see it move slightly here. If you aim directly at the block, you will see it lightly move. That's 6 thousandths of an inch, which is dead on. We're gonna move on to the piston and rod installation. On the next step, we have to measure the rod bearing clearance. So in order for you to do that, you have to split your connecting rod in half, your end cap. You have to insert your bearings inside, so we're gonna go ahead and do that now. You guys can see the bearings have been inserted, and there's an orientation. The bearing has an orientation for you to insert it on. It's literally impossible for you to put it any other way. It only goes one way and one way only. So you're gonna put the cap. Normally I use literally my hand to bring it in, and then by hand I thread this bolts in so I can get a feel for that thread, make sure it's nice and clean. They should go nice and smooth. You shouldn't feel any resistance or any dirt in there. You're gonna grab your rod bolt stretch gauge. You're gonna zero it out. So once we have that zero, I like to repeat the zero process 3 to 4 times just to make sure I have the average of them. There's better gauges out there. I happen to get stuck with this one, and I personally don't have a need to replace it. So we're gonna follow the manufacturer specifications. Initial value, it wants 55 foot-pounds, a stretch value of 55 to 60, so that's 5.5 thousandths to 6 thousandths. So we're going to torque the rod bolt to the initial 55, and we're gonna measure and determine our stretch. And again, you have to keep a nice, smooth, single motion pass so you don't change the value of the torque. So you're gonna insert your stretch gauge, and we're gonna measure. So it looks here that we're getting, make sure we're at dead center. Make sure I center this perfect. We're getting 6 thousandths at 55 torque. So that's a dead on, a stretch and torque value. And then we just repeat the process on the other one. So if you do have a vise, and I extremely recommend it, doing this on a vise, you flip your connecting rod and you follow the next step. So you take a reading, you zero your gauge, remove it. In order for you to grab the zero value of your crankshaft, you're gonna grab your micrometer, you're gonna insert into your crankshaft, and you're gonna make sure you zero your micrometer to that crankshaft. And you must get very, very slight resistance. And if your crankshaft is properly machined, you should have the same clearance on all your journals, 1, 2, 3, and 4. So you should grab, and you should be able to grab one measurement of a one journal and insert that same micrometer reading into any other journal with very ease. So we know that this crankshaft is within, I would like to say, maybe 1/10,000th off, if not even smaller, because the same journal measurement that I grabbed on cylinder number 2, I think it is, fits on 1, 2, 3, and 4. So it's dead on. We call it dead on. 1/10,000th is extremely small. So now we're gonna go ahead and remember, these are already torqued to spec and stretched. We're gonna insert the bore gauge and we're gonna find that true center on the connecting rod. And remember, I'm making an open down motion for me to find that 0 value again. So once we found it, remember, this gauge is measuring the highest peak point of the gauge travel. So that is 0. So we just give it a nice twist, make sure we're dead on. So we just remove the bore gauge, we insert into a micrometer, and that'll give us a whooping value of 2,000 oil clearance. And that is right around 2,500, which is perfect. The reason why we have a slightly extra oil clearance is because this motor, it is a race motor, and it's going to run 20 W50. And again, on this particular bearing set, we have with the purpose, we have extra clearance, half of the bearings, and standard clearance, half of the bearings. So normally when you get extra clearance on the bearings, it's around 5/10,000 extra. So that's why you get a little extra clearance. So we mix and match them depending on the purpose of the motor to achieve that perfect clearance. So once we have done that with one connecting rod, we follow the same procedure for all the other connecting rods. And if they all checked out within spec, we go ahead and assemble our connecting rods with our pistons. We go ahead and do our piston ring orientation. These piston rings have been gapped already. We do not record that, but we will do a specific video on how to ring gap piston rings. Once we assemble these components, then we go ahead and insert them into our block, retorqued following the same torque value from our measuring bench. From our bench test, we follow. So now it's time to talk about this cylindrical looking thing. It's actually called a wrist pin. This is what holds your connecting rod to your piston, and it slides through this particular area, just like so. And it goes into your piston, just like so. And it goes in just like that, okay? And then the whole piston is there. But we must also talk about the wrist pin locks, and these are wire locks, okay? There's several designs. You got ones that use, these are the C-rings, I think they're called. And some other ones, they have some sort of like a pincher design, and some are wire locks, spiral locks, correction. I think these are wire locks, if I'm not mistaken. I think they are wire locks. Anyway, to put these things in, it's quite tricky. And I think this comes with experience over time. And I like to use advice. We put a rag in here just so you don't damage your piston in any way, absolutely. So I like to insert it, the piston, and very lightly, I put very gentle pressure on it. So you guys can see, I can still wiggle it, but it's got some sort of position that I can retain the same. So what I like to do is I like to follow this group here, that it's either to remove the lock or install the lock. So what I start with, it's I position one end inside, and then the other end as close as possible to that groove. And I hold it with one finger in, follow the screwdriver, and I insert. I'm gonna have to kind a little more pressure because it's sliding down. What I like to do is I press with my thumb like so, and I putting pressure down, I insert just like that. And you got to be careful because if you don't put this in right, they'll shoot up like crazy. So now that it's not all the way in, as you guys can see, kind of put my finger on it because they do shoot up. So what I do there is I just run a screwdriver into it, and then lightly I press into it. Once you hear that click, you guys can see it's properly in there. So now you get to go with your rod setup. So you get to insert your connecting rod like that to your wrist pin. And this is temporary because I still have to redo this, and I have to do the piston ring orientation and whatnot. But so that holds one way, and then you insert another one, and it holds the whole thing in place just like that. So the next thing we have to talk about is piston ring orientation. And what we like to do here is we like to follow the manufacturer specifications. So if you do buy a piston set, it's gonna come with paperwork. Keep that paperwork and follow the manufacturer specification for the piston ring orientation. So let's go ahead and do this. So we have already prepped this piston to get it ready. We're halfway in. I personally like to have a nice, not groovy, extension across so I can hold my piston in there. Some people like to use a sleeve. I learned with this particular design. This is it. I don't even know what to call it, but you twist in there and then it compresses the piston rings. This requires a slightly more knowledge to use. So I like to position my piston rings. These are already positioned. Your oil control and your scrapers, your secondary and your primary compression rings. So I like to keep everything in place. And if you do happen to see for some odd reason, for whatever reason, you see some sort of like weird lint on the piston, just pull it out. Lint, it will absolutely not cost anything. So I insert my ring compressor and I push it forward, and now we're gonna get the view from above. I start to twist, and as I'm twisting, as you guys can see on that gap, you can see my ring gap. So what I like to do is I like to twist and I maintain my ring gap. So I'm not moving my ring gap, I'm twisting and moving my ring compressor to maintain my ring gap in the orientation that I want. So once I keep following, I keep following, and then once it bottoms out, that's it. Then I lightly lift up my extension. Again, this is my personal preference, never had an issue. The internet world is full of dummies, and people are gonna say, oh no, that's not how you do it. Well, you can learn your way. This is how I've been doing it, and it's been working very, very good for me. I build countless motors, and they're all running. So now, I like to put a ton of pressure on this ring compressor. So I literally put most of all my weight in it, and I slightly shove in there. So now we get to remove it. So now that my piston is inside, I guide my connecting rod into my crankshaft, insert. So now that we're in there, we grab my other end cap. We put assembly gel. I like this stuff a lot because it's super sticky. It won't run off like regular oil. We insert the cap on this side, just like so. Again, we're following the orientation. That's great. We just drop the Allen key bolt. So we're gonna continue to record that section there. past my dumbass dropped a connecting rod bolt. So as you can see, it's super dirty now. So now we have to take extreme precautions on cleaning it to make sure we don't leave any of that dirt in the groove. So what I like to do is I shove my nail in there and I twist as if I was tightening the bolt, and that'll clean the entire threads completely. So you guys will see shortly. You guys can see the threads there. See, now the threads are extremely clean. Bolt's good. So now we grab some ARP lube again. We nicely lube the whole thing. Be generous with this thing. You need a little bit of this stuff. So now I shove, generous but not in a huge axis. So you clean off the leftover, and because of the boxer design of this Fa20 motor, you have to rotate your crankshaft a certain way for you to achieve the desired position to tighten these bolts. So once we have achieved that position to tighten the bolts, we go ahead and complete this installation. Remember, we still need to do the final torquing procedure on this connecting rods, but for the sake of this assembly, that way we can move it slightly faster and do the other two on the other side. I just untie these, and then we torque at the end, all four at the same time. So once you're done, you're gonna give this motor a spin, and if you manage to get your proper ring gap in the same place, you will see a little tiny oil streak on both cylinders, and that'll let you know that you follow your ring orientation properly. And that's it. Now all we do last is we grab a clean wipe, and I use these, I don't know what they're called, Kimtech. These leave very to no residue lint. Just give it a nice wipe. Bring on the piston, give it a nice wipe. Turn one more time, wipe. This will get rid of all that leftover oil from the assembly. And when you're done, this is your final result. For content like this, subscribe to the channel. Final product.